It's Moser, back with another tutorial. This one, percent yield, the real deal. So, what you should know when you leave this video. You should be able to calculate the percent yield of any reaction when you're given the masses of each reactant, based on the limiting reactant. Oh dear. What you should already know coming into this. Number one, what percent yield is, how to find the limiting and excess reactant, and how to predict the amount of product that's theoretically possible from a reaction. Okay, what controls how much product is made? The limiting reactant! It literally limits how much product can be made. Why does that matter? Well, this is why it matters. Up to now, when doing percent yield problems, we've been given things like this, and this is actually an old problem. We're given an equation. We're told that some amount of something reacts in excess of the other reactant, and how much we make, what's your percent yield. So all you have to do is plug in the thing that's limiting, predict your amount of product, calculate percent yield. Easy peasy. Well, now we're going to change that up. Now you will see problems that look more like this. We still have our formula, our balanced chemical equation. We still have mass of a product. We still have a mass of a reactant given. But instead of saying that this is reacting with excess one of them, we're just told the two amounts of reactants we've got, and we're given a product. Oh, so our first step is actually, in fact, just to figure out which one is the limiting reactant. Okay, well, let's start that process. We'll move things around a little bit to clear the deck. As you probably recall, our first step when we want to find which is the limiting reactant is to do a factor label that compares the two reactants. I'm going to start with magnesium just because it's listed first. So I've set up my factor label. I have, as always, started with my given. I've made sure that grams of magnesium cancels, moles of magnesium cancels, moles of oxygen cancels, and I end up in grams of oxygen. And the answer I get is 253.722 blah 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 grams of oxygen. What am I saying? Well, you might want to pull out your sentence paper. 385.5 grams of magnesium could react 253.7 grams of oxygen, but we only have 248 grams of oxygen. Therefore, oxygen is our limiting reactant, which means oxygen is what's going to control how much product we can make. So, the good news is, we don't care how much magnesium is left over, so we don't have to do another factor label. We just had to know which one was limiting. Okay, so, good. Now what? I'm going to set that off to the side, and now I'm going to do a factor label that takes the amount of oxygen available and predicts how much magnesium oxide we should be able to produce with that. Okay, here we go. Alright, I've set up my factor label. I'm starting with the mass of oxygen that I'm given because that's my limiting, and it's going to control how much product I can make. I've converted from grams of oxygen into moles of oxygen, gone through a mole ratio to get to moles of magnesium oxide, and then converted moles of magnesium oxide to grams of magnesium oxide. My final answer? 624.805 grams of magnesium oxide. But wait! You're not done yet. What is this number? Well, this number is our theoretical yield. I've written down the equation for percent yield, actual yield over theoretical yield times 100. Now let's plug in some numbers. I get a raw answer for my percent yield of 95.9693, etc., etc., etc. I'm limited to 3 sig figs by my given oxygen, so that's going to force me to round here, and this is going to be one of those weird ones that rounds up to a 0.0. Final answer? You have achieved a 96.0% yield. Not too shabby. So, to recap, when you're given these kind of problems, you first have to figure out what's the limiting, then, based on that limiting, predict the amount of product that can be produced. Then, you can go ahead and do your percent yield. Okay, happy practice!